So in this class I'm going to look at solving problems involving combinations. And remember, we said a combination is a way of selecting distinct objects from a collection when the order is not important. And combinations can cover several permutations. So for example, I choose two letters from the alphabet, A, B. That combination, that's a single combination, but it can be written as B, A. Now that's the same combination. I've only got one combination here, but I've got two permutations of the same combination. We had a combination formula which you should learn by heart. N choose or is equal to n factorial divided by or factorial times n minus or factorial, which is the same as n permute or divided by or factorial. 6 choose 2. I want to apply my formula here. The other thing I will mention is that you will often see this written with this notation, 6 choose 2, in that way. Applying my formula, that's just going to be 6 factorial over 2 factorial times the difference between 6 and 2, which is 4 factorial. Now what happens here all the time is cancellation. So if I rewrite the top, I'm noticing this 4 factorial on the bottom. I'm using the bigger of the 2 factorials. 6 by 5 by 4 factorial over 2 factorial, which is 2 by 1, times 4 factorial. And what you will get here always is some kind of cancellation. So we get 6 5s divided by 2. That's 30 over 2, or 15. 10 choose 2. And again, you want to get to the stage where you can do this quickly. I already know the answer here is 45 just looking at that. How am I working that out? Well, I know 10 choose 2 will be 10 by 9 over 2 by 1. I know that, which is 90 divided by 2, which is 45. So where does that come from? Let's go through it again. Look at the other notation. 10 choose 2 equals 10 factorial over, by my formula, 2 factorial times 8 factorial, because 8 is the difference between 2 and 10. And then on the top we'd have 10 by 9 by 8 factorial, and on the bottom we'd have 2 factorial times 8 factorial. The 8 factorials will cancel to leave me with 10 by 9 over 2 by 1. Okay, looking at this one again, I already know my answer is going to be 20 by 19 by 18 over 3 by 2 by 1. I already know that. And I know that 3 2s are 6, and I can factor 6 out of 18 3 times. And I know that 3 19s are 57. And I know that 2 57s are 114. And if I multiply that by 10, I get 1140. So I can work it out pretty quickly. How do I get to the second last line? Well, 20 choose 17. In the other notation, looks like that. It's just a notation issue I'm highlighting. On the top, that's 20 by 19 by 18 by 17 factorial. And on the bottom, we would have 17 factorial times 3 factorial. And the 17 factorials will cancel, leaving me with 20 by 19 by 18 over 3 by 2 by 1. Okay, 7 choose 2. So you can work them out by hand and then plug them into your calculator. Okay, 7 choose 2 I know is going to be 7 by 6 over 2 by 1. So I know that's going to be 21. I know 8 choose 2 is going to be 8 by 7 over 2 by 1. How do I know that? That's the question. Just apply the formula, look for cancellation. That's what you're going to find. 2 goes into 8, 4 times 4 7s, 28. 30 choose 28. Well, I know that's going to be 30 by 29 all over 2 by 1. There's going to be 2 terms in the top divided by 2 by 1. 2 by 1. How am I getting that? Again, write out the formula. Look for any cancellations. 30 by 29 over 2 by 1. Okay, and you can plug that into your calculator if you want. The original thing, 30 shift choose 28 equals 435. Okay. So let's look at putting that into a kind of a word problem. A committee is to be selected from 5 students and 3 teachers. How many committees of 5 people are possible? Again, the order is not important. The committee of Alan and Barbara and Charlie is the same as a committee of Charlie and Barbara and Alan. There's no difference. There's no one here. They're not saying there has to be a head of the committee and there has to be a secretary and they're not given roles, which would mean we'd have to think about different things. How many committees of 5 people are possible? Well, what am I trying to do? I'm trying to choose 5 people from a collection of 8 people. It's a choose 5. And again, if you know your cancellation and how it works, that's going to be 8 by 7 by 6 divided by 3 by 2 by 1. Note to be a 5 factorial here and here that will have cancelled at this stage. 3 2s are 6. I cancel with that. That's 8 7s, 56. There are 56 committees possible. Okay, there are 56 committees possible. 56 committees of 5 people can be chosen from 8 people. And committees to be selected from 5 students and 3 teachers. How many committees of 5 people are possible? We've just seen it's 56. And how many of the committees are there exactly 2 teachers? So we're introducing the fundamental principle of counting back into this. I'm breaking this up into 2 tasks. Task 1, choose 2 teachers. And I'm choosing 2 teachers from a collection of 3. Task 2 is to choose the remaining 5 people in the committee. So 2 teachers means I'm choosing 3 students from a collection of 5. The number of ways to complete task 1 followed by task 2. Well, we multiply. 3 choose 2 is 3. 5 choose 3, well that's 5 by 4 divided by 2 by 1, which is just going to be 10. That's 30. But again, if you need to use your calculator, do, but try to get used to these things. You should be able to work a lot of this stuff out, really in your head, I suppose. And how many of these committees are there more students than teachers? Well, this, again, bringing the second fundamental principle of counting in here, there's different approaches here. More students than teachers, well, I could have 3 students and 2 teachers. Okay. Which is actually what we looked at in the second way. That's a total of 30. Or, I could have 4 students and 1 teacher. Or I could make, the committee all students, 5 students, and 0 teachers. So, again, the second fundamental principle of counting said if we're looking at different approaches, well, we can add. Or essentially means add. 4 students and 1 teacher. How do I complete these 2 tasks? Task 1, choose 4 students from our collection of 5 students. Task 2, choose 1 teacher from our collection of 3 teachers. And the number of ways to complete task 1 followed by task 2, we multiply. And then plus, well, how do I choose 5 students? I'm choosing 5 students from a collection of 5. So I'll have 30 plus, 5 choose 4 is 5. 3 choose 1 is 3. So that's 15. 5 choose 5 is 1. And that's 46. There are 46 of the 56 total committees, total possible committees, that would have more students than teachers. So 10 will not. Look at one last problem. Find the number of ways a quiz team of 4 girls and 3 boys can be formed from a class containing 10 girls and 8 boys. Task 1, choose 4 girls from a collection of 10 girls. Task 2, choose 3 boys from a collection of 8 boys. The number of ways to complete task 1 followed by task 2 is 10 choose 4 times 8 choose 3. Okay, you can do it by hand if you want. You can type it into your calculator. Let me do it by hand. 10 choose 4, 10 by 9 by 8 by 7, all over 4 by 3 by 2 by 1. 8 choose 3, 8 by 7 by 6 over 3 by 2 by 1. Where is the cancellation happening? Well, 4 2s are 8. We cancel out that 8. 3 goes into 9 3 times. 3 2s are 6. That'll cancel that 6 out. And actually we get something fairly simple. 3 7s 21 times 10, that's 210. 8 7s 56. So 210 times 56 is going to be my total amount, which is 11,760. So there's 11,760 ways to choose a quiz team of 4 girls and 3 boys from a class containing 10 girls and 8 boys. Okay, so we're in section 5.2 in our textbooks. There's nothing really in there should cause you any huge difficulty if you've understood these couple of lectures. Okay.